I'm jovell Guzman. This is my first video presentation. Hope you like it. In previous chapters, you have learned how Oersted established the relationship between magnetism and electricity. Oersted discovers that a conductor carrying an electric current develops a magnetic field around it, and I hope that you already know this fact. Did you ever think that these discoveries can be inverse? Well, that's true. That is, to produce an electric current from a magnetic field. After Oersted's discoveries, other scientists tried to find out whether the reverse of Oersted's experiments were possible. They attempted experiments to produce an electric current from a magnetic field, like the persons of Jean Biot, Felix Hayward, and Joseph Henry in 1831. It was Michael Faraday on the same year succeeded in setting up an electromotive force in a conductor which was made to cut magnetic lines of force of a magnet. These observations by them are now described as electromagnetic induction.
Process by which electrical energy is generated due to the relative motion between the conductor and the magnetic field. The discoveries of Michael Faraday and Joseph Henry paved the way for the production and distribution of cheap electrical power through the development of electric motors, generators, and transformers. There is a scientist named Heinrich Friedrich Emil Lenz who do not know the established work for electromagnetic induction. So he did the same experiment. To his experiment, he conducted a law for determining the direction of the induced current in a conductor. This is more known as Lenz's law, which states that the induced current will produce voltage that always acts to oppose the change that originally caused it.
Now, let us know how the path of electricity moves from the power plant generators to our homes. Electrical energy transmission begins when the 13,800 volt output of a power plant generator is raised to 69,115 or 230 kilovolts before leaving the power station. The electrical energy is then carried by transmission lines over long distances to the first substation. Here, the 69 kilovolts transmission voltage is reduced to 34 kilovolts. From the first substation, electrical energy is distributed to the substations in the locality. At the second substation, the voltage is further reduced to 4,160 volts. The electrical energy is then transmitted through primary distribution feeders to distribution transformers. These transformers, which are found on electric poles, finally bring the voltage down to 220 volts. The electrical energy is then passed on the secondary lines. Electrical energy is carried from secondary lines by the service wire to the consumer circuit. The consumer circuit, such as household circuit, is connected to the service wire through a wattmeter, also called an electric meter, located in a conspicuous part of the building. The wattmeter measures the amount of electricity energy consumed in every home.